Welcome to episode 4, Designing for the Future. Parts 1, 2 and 3 are in the playlist. Let's get started. So here we have immerse, and you can ignore design, but it won't ignore you. So what do I mean by this? Well, today we design through various methods. Some still use UML or C4, some kind of diagram, illustrative, some kind of tactile. I'm planning, I'm drawing, while others take a code base, manipulating the code base, refactoring a code base. Some take the test and write a test, and then it works, it's green light, and then they refactor and they are designing in that sort of emergent fashion, right? Design, to me, is something that requires due diligence. It requires discipline, understanding of the discipline. You need understanding of the domain. You need technical awareness. You need to understand the domain because you have to know what you're designing for. Not everything is technical, but all of these things are mixed together. If I do a design, I'm designing a ticketing system. I have to understand ticketing. I have to understand how people use ticketing, how the business wishes to achieve it. I also need to understand scalability and other technical factors on designing that. And those categories of design is so differently focused that it's very hard for me to take the opinion that we're only using emergent or we're only big design up front. I think both are fundamentally flawed within different contexts. Sometimes the emergent design can work best in an environment like that. Sometimes design up front works best in an environment like that. It's probably a trade-off thing. I'm going to design most things up front, or I'm going to design most things as emergent, and some kind of percentage in between. You can ignore design refers specifically to how you can sit back and not do anything, kind of like organic, right? I'm just going to do stuff, and you will still be designing. The act of writing code is designing. Any decision that you make is still designing. Any constraint, anything that you decide this over that, you're designing. And if you don't take it seriously, if you're not actively participating in decisions to guide it towards a goal, it's not going to ignore you, right? You are going to be faced with refactoring, reworking, new decisions, edge cases, and things will not necessarily work out. You cannot ignore design. Here I am tweeting this, and I was talking about Scrum and a lot of other things. And Grady Booch, you can ignore design, but it won't ignore you. Brilliantly put. This is by no means an endorsement of the entire thing that I've just said, or this method, or this video. Grady Booch knows nothing of this video. He was purely referring to that sentence. That sentence is something that describes the situation about design, where it's describing that design is important. It's not saying we must design up front or we must design in a certain way. It's purely stating that you can ignore design and you must suffer the consequences thereof. So let's see what ignoring design does. Ignoring design increases change, and then we have to deal with that change. So we deal with it by reworking or refactoring. It's also difficult to modify something where you were at and where you're going to. Sometimes it's easy. We have strategies to put in effect. Maybe TDD is something that we use to try and reduce regression. And so the tools that we have need to be in place to allow us to rework and refactor and make this change. And, if you ignore design, you're also increasing that difficulty in reducing the technical debt if you don't have all these other things in place. Now, whether all those other things in place, such as some kind of continuous deployment or some kind of automation or some kind of test-driven development philosophy, it's really up for debate whether that is dealing with change or whether there was too much change, you're inducing too much change, and therefore you have the answer. And if you weren't inducing change, maybe that answer wasn't valid or necessary, right? So there's a conflict on whether change should be created. We understand that change occurs, but are we creating more change than necessary? Ignoring design solves active problems. So you tend to be focused in code and going, oh, how do I do that? What should I do here? Oh, there's a problem. There's an answer. Let me sort that out. And so you're dealing with active problems. And you do require tests. You require some way, some philosophy, some kind of process there to prevent you from forgetting the previous things, right? So you're actively solving this problem. Well, you solved problems before and you don't want to roll those back in any way. You don't want to affect them. And so therefore you're solving this problem and you need some way of checking the regression so that you're solving those other problems as well, or continue to solve those problems. Ignoring design increases the work to get to a consistent design philosophy. So if you have a bunch of developers deciding and designing various aspects in an active way at an active particular moment using sort of availability bias and things that they have in their head, whatever knowledge they have, experience they have, and they build something, it's not necessarily going to be reflected in somebody else's design. So you still need some kind of design consistency. And it's also design integration, right? So it's not just that you have a design and so do I, and they're in different areas of the code base. That consistency and sometimes the integration of those can be made more difficult. If you're sitting up front and you say, look, I know what to do here and I know what to do there, then you can design that to be interoperable, to be integrated from the get-go. Now, it is true, as you've learned what you need to learn, right, about these two areas, you could then do the design. But can you see migrating that technical debt, if that's a term, metaphor you want to use, or just the fact that we're going from state transition A to B, then we'll need to go from A to B to B to C, and so on. We'll have more transitions to make. Ignoring design, changing design as new information comes in, and that's true because every time, because you're dealing with active or available information and then you're seeking feedback, eventually down the line you're going to get feedback that will modify what you were thinking. Now, that's true of both sides, right? You can do this on big design up front, and then you've got an even bigger problem because the feedback that comes in breaks your world, right? It completely destroys what you were doing in such a manner that it's a huge amount of change. That's understood. So the hope is that you're changing things in a smaller way. But the problem there is if you're doing it too small, your steps are too shallow. You're not thinking too far ahead. You're going to be faced with a reactive way of doing things. So you're doing something and then you react because of change. You react because of change. Big design up front is the same. You're designing everything and then feedback comes in and you react to that change. Big design up front is a larger reaction, but if you add up all the smaller reactions that you're doing over a year or two with a kind of emergent design, it's still a lot of time. It still adds a lot of weight, and you're still making mistakes and still reworking and refactoring. And so it really does increase costs. We're not saying emergent design is always, and it can't be. It's always correct. It's always just, we just have to tweak it. Oh, we just have to tweak it. We didn't have to change much. Refactoring was quite easy. We didn't change the behavior. Whatever. You might con yourself into thinking that it's minor, but you didn't have to. If you didn't have to make that change at all, it's always going to be on the wrong side of debits and credits, right? It's always going to be something that just adds to the cost. And so whether you're taking micro steps and then, one step back, one step forward, and so on, if you're doing that kind of shuffle, it doesn't matter if it's micro, you're still adding to it Micro might feel like, well, it didn't cost us too much. Look, it only took a day to do that. But the thing is, it's a day here, day there, day here, day there. What do we want to achieve, right? So that's like some of the problems, and you can think of a whole lot more, but what do we want to achieve? I want to focus on some positive things. So what we want to do is tread less water, right? We want to reduce unnecessary things. If I can see what's coming on Thursday, I want to do that now so that I don't have to rewrite what I'm doing on Thursday. And so too for next week or the week after. This isn't designing up front. This is like weather forecasting. This is like saying, look, I understand that tomorrow's weather will be 90% correct, and I understand that next week's will only be 50% correct, and therefore I'll make a decision. Sometimes that's far better than not looking at the weather at all, and that's where we seem to be. A farmer has to understand what is happening at any time, has to understand the water coming down, hitting the crops. When can he harvest? What can he do on what day? If you don't have the weather forecast, at least giving you a hint on what you can do and what you may or may not be able to do, you're really lost. And that's just sort of hitting your head until, oh, it's sunny days. Good, let's take advantage. That's one way of working. But trying to forecast a little bit ahead, trying to get better at forecasting, is a worthy activity. What do we want to achieve? Design decisions that conflict with other design decisions. So that we don't want that situation, right? We want a careful analysis of a bunch of areas and get some kind of consistency. We want to reduce integration issues with design. A robust, longer lasting infrastructure and structural code. So when we design something, it would be nice if that lasted a bit longer, right? If we didn't have to modify the internals, the structure, the algorithm, we didn't have to change the design for a while, right? Maybe 4 months, maybe a year. Wouldn't be nice for 10 years. That would be fantastic. A robust, longer-lasting infrastructure, structural code. This is architecture as well. Increased business capability and agility. And I've got there, true agility lies in the code. Now, this is something that I feel is missing. We have project management, we've got methodologies, we've got these kinds of angles. Looking at the work, it's a software, it's software work. Looking at it and saying, well, only if we didn't have that meeting. Only if we had more daily stand-ups, only if we spoke about retrospectives to squeeze out some waste, and then we'll be more efficient. And all of it's neglecting the elephant in the room, which is the code itself. Like, you're only going to be as fast as you can be given the context and the condition of your code. If your code is absolutely dreadful, huge amounts of technical debt, very difficult to put in more business capability. Everything's brittle. It's a very difficult code base to work with. You're not going to achieve much, maybe 1%, 2% better in just getting your process organized, more communication. Maybe you'll get 2%, 3% out of that. But you're going to knock 40% out should you rewrite that section, redesign that, and change this, right? The code has got more value, more possibility for agility. We also want to reduce any technical debt. We want to do that as quickly as possible. We want to increase horizontal use of what we're busy working on. So often applications are built so they start at the bottom and they just increase to the top, and the features are at the top. That's what the user sees. Underneath is just technical stuff that we have to achieve in order to deliver this to the customer. That's it, right? Horizontal is saying, well, what other business unit requires logging? What other department requires this or that? Why aren't we upgrading our dependencies at the same time across different teams? Why aren't we coordinating in some sort of way? And why isn't our code, right, whether it's encrypting something, decrypting something else, files, image management, product stock, whatever it might be, why isn't it coming from a central place? Right? Why can't we build some horizontal reuse? increase design height. And so this is the capabilities of the business. We want to be able to increase the height, the capabilities, the features, without really affecting the bottom structure. Why can't these two things be separate? If they are separate, we can deal with them on a separate kind of change rate. We can deal with them separate based on how we implement, what kind of dependencies we do when we upgrade, and many advantages. So having design width and business capability in terms of height, we're fattening our experience. We wish to boost design thinking across the team, have everyone thinking about design. It doesn't mean that they're implementing everything they think of, but just not ignoring design. Separate platform from application, offering us decoupling and high cohesion. So that kind of goes in hand with the design width and the height, the capabilities. If we separate something from platform from application, just like you would hire, or build a framework or utilize an existing framework, you use React. Therefore, why? Because you get benefit from using React. If you had to build React every single time in building an application, what are you doing? You're basically starting again. You utilize React, well, now you're starting at a few steps higher. If you use React and React keeps changing and you have to upgrade and follow, well, then you've got a different set of problems. But the point is, if you separate the platform from your application or business capability implementations, you're keeping cohesion. You're saying business that side, platform that side. This is how we deal with platform. This is how we deal with business capability. We want to increase feedback and agility, but we want to do it wisely. We don't want to tread water. We want the feedback to come in and say, yes, that's as we expected. Here's a quick solution. We've already got the solution. Our technical platform is capable of achieving that business capability. Increase feedback and agility, reduce over-under engineering. Now, when you're increasing your feedback and you want to be more agile in your code, you could be susceptible to over-engineering. And we don't want that. We want feedback to come in, and we want to be able to build something just in time or have it ready. And it was done just in time, right? So a month or two ago, we redesigned bookmarks. It can now do this and that. It can be synced and stored across multiple devices. We've got that. We haven't done the final 15-20% because that's deployment and upgrading the platform and getting a few things going. We get some feedback in. A ton of our customers are complaining about that. It seems to be a big deal. Our competitors have just done something along those lines. Why can't we? Only 15-20% more to go. Let's go and do it. Integrate the new platform into our application, gain from that technical capability, push the capability forward to the user. Now, this allows us to not over-engineer, but to do just enough so that we are ready at the precipice to move forward in something should it come in. And we could do that too much, but the right kind of forecasting can help us control and plan. We also could provide another business channel, a developer experience. Our platform could serve as a framework for others horizontally within our application. But of course, we also have this opportunity to release a part of it as open source and benefit from another entirely new channel could open up for your business.